Hi, I'm Brian Larson, Director of Partner Business Development at Broadcom, and I'm here with Howard Johnson, who is our Brocade Technology Architect for Ficon. Welcome to the Ficon Expert Series. Today we're going to talk about our Gen 7 platform, which supports the autonomous SAN and a specific feature, an integrated feature called port decommissioning. But before we jump into that, Howard, could you walk us through the challenges that a Ficon administrator has with taking a channel offline?
Absolutely, Brian. In fact, you might ask, what's so hard about taking a channel offline?
What is so hard about taking a channel offline?
Gosh, Brian, I'm glad you asked, because that's one of the things that we're trying to simplify. The thing about taking channels offline is that they are sharing a lot of resources in the System Z environment with many, many applications. And so the problem that administrators have is that when they were trying to do a maintenance operation and they're trying to take one particular path out of service, they have no idea how many applications are actually using that path, because the Z environment is so awesome at abstracting the I/O paths and sharing resources across the entire sysplex. So typically what happens to administrators is they use some sort of a manual process to take that particular channel offline, and somebody gets out there and they try to do that maintenance action, and they actually pull the link out, and boom, some application stops running. Immediately you see IFCCs on the operator console and everybody's up in arms. Shoot, you have to start the maintenance operation all over again, restore things back to operational status until things settle down, and then reschedule the maintenance operation.
In my experience way back in my career, when I was in tech support, I remember taking calls about box channels and things like that. And if I remember correctly, it had to do with someone taking an I/O path down and there was a user on that channel. Does that ring a bell with you?
Absolutely, it does. Whenever a channel is trying to drive I/O to a particular end device, it's going to do some verification along that path to make sure that the end device is the guy he wants to talk to. If for any reason the channel's not able to complete that communication over a period of time, it's going to give up. And that's the boxing condition that you've been familiar with. And that's the kind of thing that we want to avoid anytime we're doing a maintenance operation. It's still very much a best practice operation to block a port when you're trying to do work on it. But the key here is trying to figure out who all is using that port before I block it. Okay, so in the work, and I know you've been personally involved with this work with IBM Z and Poughkeepsie, the solution is a co-developed integrated solution between the IBM Z processor, the operating system, and the SAN itself, and communication between the two to help resolve this and to eliminate the possibility of doing it. Maybe you could give us an overview of a little bit more detail on how that solution works. Yeah, the solution that we came up with is called port decommissioning. And it's really a function that cooperates between the SAN and host programming. The user utilizes the SAN nav management tool to indicate which port is going to be taken out of service. SAN nav then sends a message over to the ZOS system and asks, can I take this port out of service? ZOS looks across all of the shared resources and all the shared paths and recognizes which path is affected by that particular service action. ZOS then moves the I/O from that path to all the other paths he has available and isolates that particular path so that there's no I/O flowing on it. He then responds back to SAN nav and says, hey, I've taken all of the I/O off that path. You can go ahead and decommission that port. SAN nav then goes down and tells the switch, go ahead and block that port. He'll block the port, and none of the applications will have any idea that particular maintenance operation has gone on, because their I/O continues to flow across the other available paths. When the maintenance operation is complete, the administrator simply tells SAN nav it's time to recommission that port. SAN nav sends another message over to ZOS, who then can move I/O back onto that particular path, and now that resource is back in use. Very simple.
Yeah, I'm glad you mentioned that, because the naming convention of port decommission didn't say anything about recommissioning or bringing it back online. So then to summarize, though, this is an automated and a coordinated effort between the systems and the SAN, and it really helps just eliminate troubles and maybe some human errors in that manual process when trying to identify if a user is on that path. So that's pretty much summarizes it, correct?
That is correct. This, port decommissioning is part of our autonomous SAN messaging that we have as part of our Gen 7 offering. And this is one of the elements that has been actually a part of our toolkit for Ficon users for quite some time. It is just now coming into much greater status because of the requirements of safe switching in System Z environments.
Could you just give an example, however, of when this might be used? Just a simplistic example in a maintenance action that might take place and how this can help avoid anything.
Oh, certainly. One of the most common elements to be replaced in an environment are the SFPs. That's the little optic that plugs into the switch or into the channel or the control unit. Let's say we have an SFP that we've noticed is starting to fade. That is, we can see that the power levels on that SFP have been dwindling over time. And we know that any time that SFP will finally fade to the point where it needs to be physically replaced. So what we want to do is schedule a time to do that maintenance. Since coordinating the activities between a whole bunch of users and applications is very difficult, it's much easier to do this with port decommissioning. The administrator simply walks over to SANNAV and says, I want to replace the SFP. He selects the port and says, decommission the port. SANNAV communicates with ZOS. ZOS says it's okay. And now the administrator can walk over, unplug the cable, pull that SFP out, put a new SFP in, reinsert the cable, and then walk back to SANNAV and say recommission, and now everything is running. So we've done a maintenance action that oftentimes, without port decommissioning, requires several weekends to get scheduled because of the start-stop nature of manual processes. That is, somebody didn't get the memo and they left their application live and it got impacted by that particular maintenance action and it had to be backed out before they could complete the overall operation. With the autonomous SAN feature of port decommissioning, that's all done behind the scenes and the applications can keep running during the entire operation.
That's fantastic. So it's a real time saver. It gives the administration and the users confidence in the fact that when they take this action, everything is clear and ready to go, and that they should be very confident that when they are done with the operation, things can come back online just as they normally would. So it sounds like a win-win for everybody involved. Well, that's about all the time we have for this video. But on behalf of Howard and I, we want to thank you very much for the time. And if you want any more information or resources, please visit our Broadcom SAN mainframe page. Thanks for watching.